Hey guys, in this video, we're going to discuss Leetcode 2289, the number of steps to make array non-decreasing. So basically for this problem, we're going to be given a zero-indexed integer array nums, and in every step, we're going to remove all the elements nums I, where the previous item for this number is larger than the current number. And we're going to return the number of steps we performed until the array becomes a non-decreasing array. So let's take a look at example here. And see if we have an input of these. So the first step is like we're going to remove all the values where the previous value is larger than the current one. So this 3 is smaller than 5, so the 3 going to be removed. And for the 4, the 3 is smaller, so the 4 is okay. And this 4, the previous value is equal to this, so it's okay. And for this one, the previous value is smaller, so that's fine. And for this 3, it will be removed because the previous value is 7, which is larger than the current value. So this 3 will be removed. And for the 6, it's larger than the previous value, so it's okay. And the 11 is larger than previous value, so it's okay. And for the 8, it's smaller than the previous value, so the 8 will be removed. And the 5 is smaller than the previous value, so 5 is removed. And the 11 is larger than previous value, so that's okay. So after we remove all the values in this first step, the array will become something like this. And now we're gonna do the same thing again. So this 4 is smaller than 5, so this 4 should be removed. And the second 4 is the same as the previous value, so it's okay. This value, 7, is larger than 4, so 7 will be kept. And the 6 is smaller than 7, so 6 will be removed. And 11 is larger than 6, so it's okay. And this 11 is equal than the previous value, so it's okay. So this time, after we remove 4 and 6, the new array will become something like this. And then we're gonna look at do this again. So the 4 is smaller than 5, so it should be removed. 7 is larger than 4, it's okay. 11 is larger than 7, it's okay. And 11 is equal to 11, so it's okay. So now after the third step, the new array will become something like this: 5, 11, 5, 7, 11, 11. And it's a non-decreasing array. So that's the end of the output. So we're gonna return 3 because we have removed elements from the array in 3 steps. So for this problem, what we can do is we can, instead of looping through from the index 0 to the end of the array, and check if the current value is smaller than previous value, and do it multiple times in a naive approach. What we can do is we can do it in the opposite. We can loop from the end to beginning and use a stack to keep track of the current value, and then we can just make sure in the stack the current value is always smaller than the previous value, so that in the stack we can make sure the values in the stack is the numbers we process in the array will be non-decreasing. So that's how we're gonna solve it. So we're gonna use a stack and to solve it. So let's take a look at example here, and we are gonna walk through how we're gonna solve it with a stack. So let's say the input numbers is 7, 14, 4, 14, 13, 2, 6. And this is input number, and this is the index of the numbers. I just gonna keep track of. So the 7 is on index 0, 14 is on index 1, and so on and so forth, and 13 is on index 7. And then the response array is we're gonna just keep track of for every index, right? For this number 14, how many moves we're gonna have for the number 14. For example, 13 is smaller than 14, right? So there will be a move of 1 for 14 because 13 will be removed as it's smaller than 14, right? So that's every in the response array, we're just gonna keep track how many steps or moves we have for this number. And then, of course, we're gonna have a stack to keep track. As I mentioned, we're gonna use a stack to solve the problem. So we're gonna loop from the end of the array. So let's say the first item is 13, right? So we're gonna just, since the stack is empty, so we're just gonna push 13 into the array, and the 13 is at index 7. So I just gonna keep track of the index of the number as well. So we're gonna push the 13, which is at index 7, into the stack. And the second value is 6. Since 6 is smaller than 13, so it's okay, we're gonna just keep push it into the stack. And the next value is 2. The next item is 2. So 2 is smaller than 6, so we're gonna just push it into the stack. So it's at 2 is at index 5. And now the next value is 13. All right, so 13, right? So now we're just gonna check that like in the top of the stack, 2 is smaller than 13. So we know like for 13, we're gonna have one step to move the 2, right? So we're gonna increment the response array for 13 by 1. Now we remove the 2 at index 5. And now 6 is also smaller than 13, right? So we're gonna remove 6 as well because 6 will be removed from after 13 as a second step. So 6 will be removed, and then we have incremented this by 1 again because we know like after 13 there will be 2 steps of moves. First move the 2, and the second move will be remove the 6. All right, and now we're gonna push the 13 into the array, which at index 4. 13 index 4. All right, the next number is 14. Okay, so now this is 14, right? And the 14 is larger than 13. So now we're gonna increment 14 by 1. But now this value shouldn't be 1 because for this 13, we need 2 steps of moves to move the 13. So this 14 should be like the initial value should, when we increment, it shouldn't be 1, it should be 2 instead because when we move the 13, right, there should be another 2 steps to move 2 and 6. So that's why it should be 2. So step 1 will be remove 13, and the 2 will be removed since it's smaller than 13, right? And then the second step will remove 6. So that's why we initial value will be 2. So let me just keep a note here. So basically, the value of I as response I should be the maximum when we try to calculate the value should be the maximum of this one, like incrementing with again against the previous index. So because like the previous index, like the index 4, right, has like the value to pop, it has a value 4, so it should be the maximum of 1 and 2. So index 4, right, has a value 2, so it should be the maximum of 1 and 2. So that's why the first initializer 2 jump to 2 directly. So now we pop the 13 out, and then 14 is larger than 13 again, right? So we're gonna remove the 13 as well. So now we do it again. So it should be a maximum of 2 plus 1, which is 3, and this one is 0, right? So it should be maximum of 3 and 0, so it should be 3. All right, so now this one will be popped out, and then we're just gonna push the 14 into the array, into the stack, sorry, index 3. And now the next value we're gonna process is 4, which is smaller than 14. So that's why it's okay to push that in at index 2, right? And then the next value we're gonna process 14 again. So 14 is larger than 4, right? So now we're gonna just increment it by 1 again because we're gonna have 1 step to remove that. And then we can push the 14 in at index 1. And then the last value is 7. 7 is smaller than 14, so we can just push the 7 in. All right. So now we process the array with a stack, right? And then we have an array of response values. So we just return the maximum of the response value, which will gonna give us the maximum of steps for each number to process, right? So which is the number here, 14, gonna have 3 steps to process it. The first step removes the 3 and the 2, right? And the second step will remove 6, and the third step removes the 13. So that's why it's 3 here. So, and then we return 3 for this input example. So basically that's how we're gonna solve that with the stack. And the key point here is like how we're gonna calculate every response value. So basically it's like the maximum of the current value incremented by 1 again, and the index to remove in the previous in the stack. So basically that's why we need to keep track of the stack index in the stack as well. All right, so let's try to code it out. So now we need to initialize a response array, as we mentioned, with the length of equal to the length of the number of the length of the input, and we also need a stack. Initialize it to empty. So now we're gonna just loop from the end of the array to process the numbers 1 by 1. So for I in range of length of numbers minus 1 from end to the beginning. All right. So the number will equal to the numbers. Right. So now we get the number, right? And then we need to compare the value of the number against the last top of the stack. So while stack, and so so let me see. So in the stack, so every item in the stack will have a item in stack is should be a pair of I would say it should be a tuple of a value and the index of it, because we need to memorize the index as well. And stack of the last value top in the stack and the value, right? This is the value. So if the value is smaller than the current number, then what we're gonna do is the value and the IDX equal to the stack. We're gonna just pop it out from the stack, and then we're just gonna use this equation. So response I would equal to maximum of incremented by 1 under the previous index in the stack. All right. And once we finish the process in the stack, we're just gonna append it, the current one into a stack, and raise the num and the I. All right. And after we finish processing all the values, we're just gonna return the maximum in the response array. So let's see how it goes. Yeah, works fine. And then let me see how to run it. Let's just try to run it. Yeah, looks good. So basically, we're gonna just use a stack and loop through the array one time. So time and space will be both linear, order of n. All right, so this is the end of the video, and I'll see you guys in the next one.